So this is all about a project called LEO, Local Energy Oxfordshire. And this has got the most superlative description as being one of the most ambitious, wide-ranging, innovative and holistic smart grid trials ever conducted in the UK. Now, one of the reasons why it's focused on Oxfordshire is the electricity network in Oxfordshire is quite constrained. And so one of the project's goals is to assess if any of the advances in technology that we've seen happen can be used to find a cheaper solution and integrate more renewables into the network and see what options there are for flexibility. And these findings will be relevant across the country, not just Oxfordshire. Okay, so we're going to hear from the speakers, then have the Q&A session. My name is Helen Gavin. I'm based in the Environmental Change Institute of the University of Oxford, and I work on the programme on integrating renewable energy. And I describe myself as a sustainability professional with water and energy experience. Now, our first speaker is Melanie Bryce, and she works as the Oxfordshire Programme Director at Scottish and Southern Electricity Networks. And she's the lead for that organisation on Project Leo. And Mel is a chartered engineer and has spent her career in the energy industry, spanning roles from asset management to investment and regulation. Then after Mel has spoken, we'll hear from Scot Wheeler, who is a postdoctoral researcher in the engineering science department of the University of Oxford. Now, Scott's interests are motivated by the transition to a more distributed energy system, increasing renewable energy generation, and looking at how smart solutions can help manage this. And then after Scott, Sarah will speak on the more social aspects of Project Leo. Sarah Darby is the acting leader of the Environmental Change Institute's energy programme at the University of Oxford, and her main research interests concern the future of electricity systems as socio-technical systems. And this involves studying the social and behavioural and educational aspects of energy use, including adoption and adaptation of technology by laypeople. So our first speaker is Mel. Mel, would you like to take the floor, please?
Absolutely. So I am working with Sarah and Scott on Project Leo, Local Energy Oxfordshire, and this is a project that is sponsored by Innovate UK as part of the Prospering from the Energy Revolution programme, and it lasts for 3 years and has a total value of £40 million. So as Helen has just said, it is one of the largest demonstrator projects that is on the go at the moment. So I represent Scottish and Southern Electricity Networks in the project. So Scott, if you go to the next slide. So Scottish and Southern Electricity Networks are obviously interested in all of the things across the energy network. So although we're more involved in the operational and technical sides, we're also very interested in the social side. And that is represented here in what's commonly known as the energy trilemma. So we need to be reliable, we need to be affordable, and we need to be sustainable. And we very much build our strategy around the 17 sustainability goals that are put forward by the UN. And we're very much looking to get emissions to net zero by 2050, and being part of Project Leo is going to help us to do that. So next slide, please. So in Leo, we are very much looking at moving from being a distribution network operator to be a distribution system operator. And this can be demonstrated using the analogy of a road. So if you're traveling on a road and it's nice and clear, then you can get from A to B really quite easily. If you do the next click, Scott, and then sometimes we have it much busier, so there's congestion, and if we've got lots of congestion on our road, it's a bit like having congestion on the electricity network. We need to do something about it. So next click. So we can either invest in the network by doing things like putting in flyovers if it's for transport, or the analogy for the electricity networks would be to reinforce the network, but this is quite an expensive option. So next click. So we also are able to use things like active network management to manage the constraints on the system. So for roads, this is sort of like traffic lights, but for us, we can look at matching generation to demand in real time with specific generators. Next click. So we can also look at smart solutions and flexible connections. So this is things like time of day and shared use. So for example, if you wanted a connection and you knew that there was someone who had an equal sort of demand generation mix, then you can apply for a flexible connection. And then last click, I think, on this animation. So we can also look at pricing signals as well. So this is part of what we're doing in Leo, is looking at the markets and making sure that we can get the right price signals to alleviate constraints. So next slide, please. So yeah, so Project Leo, absolutely great project. We've got a wonderful team of people on it. You know, we've got 9 different partners from right across the energy supply chain, and we're all looking at, you know, the main reason for doing the project is to be the first building block in the decarbonisation of the entire county of Oxfordshire. So it is a very prestigious project, and it does bring in partners from right across the energy supply chain. So yeah, so we're really, you know, looking forward to all the learning that's going to be coming out of it. So next slide, please. So yeah, so this is very much the sort of data flows in the project. So SSEN bring the transition project to Leo. So transition is an Ofgem funded project, and very much looking at the IT systems and the OT, so operational technology, communication systems that we're going to need to enable DSO, distribution system operation. So we've got 2 key systems. The first one is the whole system coordinator that is going to interact with our systems. And then we have the market facilitation platform, which very much sucks in all the market data from people like Piccolo, Origami, EDF, Nuvei, this sort of aggregation platforms, and some of the other market-based platforms, so that we can look and see how we can alleviate constraints on the day. And then we also have all of the DER, so the energy providers, so be that wind or batteries, or be it demand side response. So all of that comes together, and those are the data flows that we have in Leo and transition. So next slide, please. So yeah, so Oxfordshire is obviously quite a large county, and we need to run trials to demonstrate that the IT and OT systems work, and also that all those data linkages can work together. So we have done some site selection procedures, and we've come up with trial zones across Oxfordshire that are made up of 12 primary substations. And these are grouped around what we want to find out during the project. So we have a zone which is very much about heat networks. So this is where potentially it's a rural area, lots of oil-fired heating. Potentially we can see what the change would be if we were able to go to low carbon heating in that zone. In another zone, we have behind the meter. So this is very much in the centre of Oxford, looking at university buildings and how we can optimise behind the meter. And then we have other zones that are looking more at communities, so looking to see what the impact of the energy transition is likely to be in different sorts of communities, you know, those that are more affluent, less affluent, more likely to have an EV, more likely to live in not owner-occupied dwellings, for example. And then we have other areas that are sort of all-rounders, so these are ones where we've got quite a high density of potential assets that we're going to be able to trial as well. So those are our key trial areas. Next slide, please. So yeah, so this is very much the timeline that we've got for Leo, and we are using the agile project management approach and developing a series of MVSs, or minimum viable systems, that we can deploy, you know, early on in the project and get learnings out. So we're currently at the stage of MVS plus, so we're very much looking at improving the comms in our MVSs, and also adding to the number of assets that we have, run more trials and make sure that each of the interfaces are working properly. You'll note that the full trials go on after the end of Leo, and that's because the transition has a slightly longer time frame than Leo, so much prepping up for the full trials, and we'll be able to start testing our IT/OT systems towards the front end of 2021. So yes, I think that is, you know, it's a good timeline, and we're certainly moving forwards with everything we need to do. So next slide, please. There we are, I think that's me. So yes, so if there are any questions, I'd be happy to answer them.
So thanks very much, Mel. Everyone who may have just joined the call very recently, just to let you know, we'd appreciate if you could put any comments or questions you have in the chat pane, and we'll pick them up. I have one very quick one for you, Mel. Roger has asked, what does BSP mean?
Bulk supply point. So that is, each of the points on the network has a different sort of a name. So we have grid supply points, bulk supply points, primary substations, and secondary substations, and it's just the voltage conversion at that particular point. So it's just somewhere where, you know, energy is transformed on the network.
Okay, sorry, I missed the B. What was the B?
Bulk
supply points. Okay, thank you very much. Okay, and there are other questions in there, but I'm just going to wait until we've heard from our other speakers as well, but I will be picking up the questions that are in there. So Scott, would you like to leap into the fray and tell us about the technological aspects of Project Leo, please?
Yeah, thanks, Helen. So just to start with, so why are we interested in smart local energy systems for Oxfordshire in the first place? The graph on the picture on the far left is generation in Oxfordshire in the year 2000. And what you can see is there's very few sites of generation, and it's dominated by one large one, which was the coal-fired power station at Didcot. Skip forward 20 years, and the center picture here is a screenshot from the People's Power Station, which is a visualization platform which one of the partners, the Low Carbon Hub, have developed. And it's a visualization platform for different community installations of renewable generation across the county. And you can see the transformation of the number of these generation assets, which are typically connected at the low voltage at the grid edge. And this is only a selection of these. There's actually over 9,000 different registered generation assets across the county of Oxfordshire. And so what the smart local energy system is all about is how we can start to utilize all of these assets and further drive that development. Now, with all of this renewable generation coming on at the low voltage network, there are obviously challenges associated with that. And one of the big ones is the variability, both intraday and also seasonally throughout the year. And so we need to think about balancing the network in order to cope with that variability. And digitalization is one of the key kind of drivers and things which enable us to do that. So we very much think of these systems as socio-technical systems, and Sarah will talk about the social side of these systems in a second. Just to reflect on the more technical aspects of this system, there's a few points which I've noted down, which I just want to explore slightly, and how these fit within Project Leo. So first off, you need assets. So you need generation, you need storage, and you need load. And you need to make sure that you have the right diversity of these assets and the right number of these assets in order to manage a smart local energy system. And especially when it comes to flexibility and procurement of flexibility, you need the right diversity in order to make sure that you reduce your risk of non-delivery of that flexibility. You need some form of network, and in the case of Project Leo, we're looking at the distribution network, which is operated by SSEN. And our kind of definition of, or our version of local for Leo is the county of Oxfordshire. But depending on what level you kind of associate a local energy system being, then your network might change. And some of the other demonstrators that are funded in the same PEEF around as Leo have slightly different networks that they're looking at. We also need to think of the cyber physical systems around monitoring, around data storage, and getting the balance right between the resolution and the amount of monitoring that you need in order to manage that network, and then the costs of that, both financially in terms of installing that monitoring, but also the amount of data storage that goes alongside that. Linked with that, we need to think about smart control. So how do we actually optimize the different assets in order to maximize the utilization? And this involves forecasting as well, both in terms of demand on the network, but also weather forecasting and the generation. We talk a lot about digital platforms, and the image in the center of those 5 is the Piccolo platform, which is being used within Leo, and this is a way to link up the needs of the network and the competitions for flexibility, which are set up by SSEN, linking that through to the actual flexible assets from the different partners within Leo, but as Leo expands to the wider community, all of the different assets within Oxfordshire. Finally, I've noted down financial platforms and markets, and commercial is a whole theme which we could talk about in a lot more detail. But there are platforms, digital platforms, which relate just to the financial aspects of things as well. And finally, I just make note of the fact that we need engineers and installers and people to actually set up these systems in the first place. So within Leo, and Mel mentioned this a second ago, we're taking an agile approach to how we transition to this future smart local energy system. And for anyone that's been involved in software development, you'll be familiar with the lean methodology. And this is what we're trying to apply within Leo. So we start off by identifying a societal need. This then inspires some sort of theory of change or hypothesis, which we want to test. We then build what we term minimum viable systems, which is essentially the minimum set of participants or assets which we require in order to test a particular hypothesis. And within that, there could be multiple minimum viable products. An example is the Piccolo platform itself, which are being developed in parallel to this. Through running trials on these minimum viable systems, we then measure against KPIs and processes. This enables us to learn about our hypothesis, and from that we're either able to adapt the hypothesis to better suit the need, or we might actually understand our societal need better and shift what we actually think the system requires. So the first year of Leo is largely focused on developing largely technical MVSs around flexibility service delivery. We have 5 different categories, which I won't go into detail now. I just wanted to present a quick example of one which sits within that first category, prosumer, where we have a flexible asset or a flexible site which is co-located with some sort of non-dispatchable generation. So the very first trial that we ran within Leo, the first MVS trial, was based at the Oxford Bus Company, who have a depot in Cowley, which is just south Oxford. And the site has 140 kilowatt peak PV array, and it's co-located with 90 kilowatt hours of battery storage. The original intention of the storage was actually as a buffer for charging electric buses, because there are connection capacity limits for the site. But we wanted to explore whether this battery could also be used for flexibility services for the network. So the very first trials that we ran, the main focus and the main aim of those trials were actually to test the delivery procedure that we've developed, but there was also tests around the manual dispatch of that asset, and later trials focused on moving towards a more automated dispatch of that asset and the remote dispatch of that asset. We also installed temporary monitoring at the site as well as at the local substation to try to understand better what monitoring is required for validation, for instance, and what the impact on the substation was. So there's 2 graphs here, and the main point that I want to make is how we're using these to understand what our need is in terms of monitoring. So on the left, you can see this is very high resolution monitoring, and it allows us to accurately identify when there was when the service was delivered and when the flex event happened. So this was for a 30 kilowatt reduction in site demand, and you can see that we can identify that to pretty much to the nearest second as to when that happened. But there's obviously costs associated with such high monitoring and like I mentioned earlier, financial and data costs. If you look at the graph on the right, this is just from the standard half-hourly metering on site. And the way that the trial actually aligned with hours makes it slightly easier to pick out where that trial happened. But you can see that because part of the trial was just before 1 o'clock, there is a slight decrease in the load between 12:30 and 1. And if you didn't know exactly when the trial happened, then would you have enough information within this half-hourly plot in order to accurately validate that the service occurred within the tolerances which were set by the network? And so there's a real balance which has to be made between monitoring and the level of monitoring versus the tolerance of the service that the network requires. And that's me.
Thank you very much, Scott. We had a few questions come in, so I'm going to take the opportunity to ask you a couple from the chat pane. Who owns these decentralized assets?
So it's a real mixture of owners. So we within Project Leo are working very closely with the Low Carbon Hub, who are one of the partners, and they are a social enterprise that develop community-owned energy. So we have a lot of assets which are community-owned. We're also looking at other partners' assets. So we're looking at demand-side response within the University of Oxford, and also within local authority buildings within the city. So some of those are buildings which are owned by kind of commercial or local authority partners. As the project progresses and as we move beyond Leo, then we'll look to open that up more and more to domestic customers and anyone that has a flexibility asset which they think they would like to take part in such a market.
Fantastic. And one more hopefully very easy to answer question. What type of battery does the Oxford Bus Company have?
Ooh.
Maybe it's not that easy to answer.
Not so easy. I am not sure actually off the top of my head, but I'll try to quickly look it up while Sarah is talking.
Thank you. Okay, let's move on now. Thank you very much, Scott. To Sarah. I mean, what's been missing from all the discussion today is people, although we did very briefly just touch on it in terms of who owns these decentralized assets. So Sarah is part of Project Leo and looking at the more social aspects. So Sarah, over to you.
Okay, thanks, Helen. Right. So I'll start off with a ground statement that large-scale problems don't require large-scale solutions, but they need small-scale solutions in a large-scale framework. I do think that's quite opposite to what we're talking about today, because we're talking about a lot of small-scale solutions within the larger scale framework of having a viable local energy system that can also link in with the national grid, of course, the much larger scale framework. And it's worth remembering that the national grid, one of their scenarios for the future is something along the lines of what we're testing now. It relies a good deal on a lot of small scale distributed solutions. So moving from the left to the right, we have the sort of system we've been used to in the past, represented in very basic terms. We've had a few big power stations, we've had a network of substations, and they have supplied electricity to a lot of users. You could say the same for the gas network. And we're moving to something that is a good deal more complicated. We've got lots of energy sources coming on stream. We've got changes in the patterns of demand, where we're going to be having shifts in the way we heat buildings and in the powering of our vehicles. That'll affect the demand for electricity considerably, not just the amount we use, but the timing of it. Storage is becoming a big part of the picture. And as well as having diverse energy sources, we've got a lot of very diverse people doing all sorts of different things all around the country all the time. And in the past, with the left-hand picture, the system hasn't needed to know a huge amount about, it hasn't needed to know a lot of detail about what's actually happening on the demand side. But now it's becoming increasingly important to understand about that. And Mel talked about the move from being a distribution network operator to being a DSO, a distribution services operator. And a big part of that transition is understanding and using the demand side much more in the operation of the system. Next slide, please, Scott. Flexibility is going to be a really important feature of our new systems. As people are very fond of saying, the sun doesn't shine all the time, the wind doesn't blow all the time. We are going to be relying increasingly on renewables, and as well as being able to store some excess supply at times, it's going to be important to make shifts in demand to match the available supply. So looking for more flexible demand has become a very important thing. And here I'm showing you a concept diagram that I and some colleagues worked out a few years ago about achieving this flexibility and what it means in human terms and technological terms. So if you look at that box, that's the potential flexibility of demand that we might have. And we can fill that box full, half full, or have it nearly empty, depending on what's happening along the three axes of the box. So the flexibility will depend partly on the technologies we have available. For example, you might be running a supermarket chain with a big fleet of freezers that could be switched on and off according to meet the sort of network requirements. Or on a smaller scale, you might be someone with an electric vehicle that you could charge up flexibly. There's the service expectations. If you've got a fleet of freezers, your service expectation would be that none of the stuff you were storing in the freezers would go off. And that would be, it's clearly extremely important. If it's an electric vehicle, you'd want to have your battery charged up by the time you went out the next day, or when you went on your next trip in 6 hours' time. And then the third dimension of this is the sort of activities that are going on and the skills that people have in operating their technologies. So it's all those three things together produce the flexibility in demand. So if we're talking about the social element in new energy systems, that's one way of looking at particularly the flexibility element of it and why the social element is so vital. Next slide, please. This slide comes from a piece of work I did a few years ago, looking at the introduction of smart thermal storage. So this is smart use of storage heaters and of water heating. And we found that there were three, we found that there we were using distributed assets that belonged to hundreds of different people, non-expert people, and we found there on the social side, you might say, there were three essential types of communication that we needed. The technologies had to connect up well. All the technologies were market ready at the start of the project, but connecting them all up and getting them to behave in a connected way was something else altogether. So that was quite a big challenge. There was then the interface between people and technologies. So there was the controls, and they had to be well designed and user friendly. And there was the question of care, which was the relationships between the people involved in the project and what sort of backup there was of skilled help and advice, what sort of legal protections were in place, that sort of thing. And Scott's mentioned the importance of installers and engineers in the LEO project. And I would say, yes, absolutely. These are crucial people because they operate on the interface between technology and people and people's understanding. So if you've got an installer who can explain to you what it is they're installing and why it matters and what you need to know in order to operate it well, that does a lot for smoothing the progress of the program. So I would just again say a working energy system, it's about a lot more than the cost, the technology readiness and the social acceptance. It's about all these interactions between technology and people that we're trying to take it into account in LEO. Next slide, please. Yes, then I've got a couple of slides. This is the first of them, just to try and explain the trajectory we've been on. So this was an early slide about how we saw things going. So digitization is also an important part of smart local energy systems. So we have to have the data available and we have to understand it in order to understand the system better. Then we have to start working more smartly so that supply and demand match up well with our new distributed supply resources and new forms of demand. We have to be able to make both supply and demand flexible to balance the network at all times. And if we can do this locally, then as locally as possible, then that makes life a lot easier further up the line. And there is, of course, the crucial insight that demand isn't just something you can take for granted and more or less ignore. It's actually a tool for managing the network. So that was a short way into the project. And then the next slide that you'll see is, I'm afraid it's very inelegant, it's quite messy, but it shows, I think, how thinking has moved on. So if you look in the blue boxes on the left, you can see the white print, which was there in the previous slide. If you then move to the green boxes on the right and look at the black writing, you can see the first set of developments. So we need more data and we need to understand it. So we then use that data to develop business models. Then we start developing software platforms, so to create a market for flexibility and energy services. And then we test out these programs using a variety of different sort of assets. So we move to the green boxes and the black writing. And then it gets even more colourful and interesting because we get the red writing, which is where we're putting in the people. With all that they can bring to the party. And we're also showing in the turquoise boxes towards the bottom some of the outcomes that we might expect, so that if this goes well, we'll have more space on the network, but also we will have developed the social capital in the county. We would hope to have better functioning communities, more knowledge, more ability together to manage the system, so that it's something lots of people are involved in. We'd be developing financial, legal, social arrangements for connecting more renewables into the system and offering more and better energy services and trying to be inclusive about this as well. And we'd be spreading knowledge and know-how. And it wouldn't just benefit the substation level, but also the people in each substation area. And the findings from the policy would also be going upstream to feed into policy and planning. So we end up with something that is a much richer, more complex sort of picture of all that we need to take into account. And then I've just got a final slide. I don't know if I have time for this, Helen, or if you'd like to.
If you don't mind, just it's a good slide to end on. So
we'll end on that, yes, and everybody can read, so we'll leave it at that. Yes.
No, please do describe it, and then we'll close.
Okay, well, these are just some of the challenges that come to my mind, at any rate, that we're meeting in Leo, and from talking with colleagues, I think we share a lot of this perception of some of the main challenges we're facing. So there's the complexity of the project, and we do try and welcome that. And we're working hard to try and develop a common language and to understand each other as well as we can, coming from our different sort of areas of work. This idea of building the social capital and building the coalition of people who are willing to make this succeed is absolutely crucial. And we're very lucky in that we have, as lead partners in the project, SSEN, who have a very strong interest in providing good network services, and also the Low Carbon Hub, who have done a terrific amount of outreach in the county with a lot of already existing lively environmental groups and energy groups, and they act as a sort of focal point for all that social wealth. So we're building on that, and we're particularly keen in building on that to try and be inclusive and to try and see that nobody gets left behind. There was a very good question earlier about who owns these assets. And there is a danger in the smart new local system that there are people who are disadvantaged who aren't going to own any particular assets, or not much that they can actually trade in these new markets. And it's going to be extremely important to see they don't get left behind. So we are doing our best to try and design to see that doesn't happen.
Okay, thanks.
Yeah, so yeah, I'll leave that there. Yeah.
Thank you very much, Sarah. Indeed, that was one of the questions just popped up on the chat pane actually. So I'll ask you this direct question, Sarah, and then we'll go to the general Q&A panel with all of our speakers, which is a question from Christine. So asking, do people receive an incentive to participate? That could be financial or other. Is there an element of the project which is investigating which groups of people may need different types of incentives to participate?
I think indirectly there is. At the moment, the main incentive to participate is really an interest in seeing that this works, I would say. As time goes on and we're hoping to develop this local energy market, then there will be financial incentives to participate as well.
Okay, cool. Thank you very much. So on with the chat and the questions that appear in the chat pane. I've one question actually for any of our speakers really. It's about the length of time of Project Leo. I mean, I started by saying it's this amazing holistic smart grid trail. It's, you know, first ever. It's got funding for 3 years, and the three of you are speaking from the position of having done 1 year, and you're revealing the complexity. Oh, it's a big project. Is it achievable? Can you do it? What's the time frame? The house is on fire. How can Project Leo put out the flames?
Well, what we tend to say is we have 3 years of funding for this, but it's a 10-year program. So I don't know, Mel and Scott would
I would agree.
Comment on this.
Yeah.
That this is kind of proof of concept stage.
Yes, definitely. I mean, Leo is very much about setting up the system and understanding what works and what doesn't work. So it's an environment where we can even fail at times, and then build a system which is then kind of sustainable to go beyond the 3 years of Leo. And all the partners are definitely signed up for that much longer vision.
Definitely, and we have you know, very good monitoring as well with Innovate UK and clear milestones that we reach as we go through the project. So we're definitely on track to fulfil everything that is required of us, you know, within the 3 years. So yeah, so I'm very confident that we're going to get out some really good learnings and be able to do, you know, trials for the transition program as well.
So who will be funding the next 7 years then? Is there an idea of, very quiet, yes, raise eyebrows, who? What's the plan there? And how has coronavirus, another question that's popped in is, how has coronavirus affected the timeline of delivery and the rate of progress that was expected originally?
Well, coronavirus has obviously impacted the project like it's impacted everything, but we're very fortunate to have got an extension from Innovate UK of 3 months. So at the moment we're still working within the time frames of the project. But the main things that have been affected are things like our supply chain for solar panels, things like the power price dropping off because of reduced demand, and then things like not being able to get out in the community and do our engagement, delays in putting monitoring equipment on the network, and a few delays in some of the projects, but we are catching up with that again now, and we've managed to get some monitors in the last few weeks, so all to play for.
and the extra 7 years funding, we can't say more than that, except we're fairly confident we can come by it. But
yeah, and I'd also say, I think if we're successful in developing the market, then the market itself should become self-sustaining as well. So that there should be incentives to actually get involved within the market as well. So it's at the moment that proof of concept is what needs the additional booster of funding.
Okay, thank you. A question about Piclo and Piclo's role in the project, and how does it work as an aggregator? Would maybe Scott or Mel, you'd like to answer that question about Piclo?
Yeah, so Piclo themselves aren't aggregators. So they are very much a kind of visibility platform where, and the platform which kind of hosts the competitions for flexibility. So they essentially advertise the fact that there is need for flexibility in a particular area of the network. And as an asset owner, you have a profile where you're able to upload what assets you have and the availability of those assets, and then make bids into the competition which has been released by SSEN. So then themselves, they're not aggregators. They're more of a way of linking the need for flexibility and those that are offering flexibility.
And so, Mel, you mentioned flexibility services. Well, what are we talking about flexible assets or flexibility as a service? Could you comment on that, please?
Yeah, no, absolutely. So as a system operator and a network operator, we potentially want to use flexibility to do things like alleviate constraints. So we've got different services, things like peak management, where we would be advertising for generators to turn up or for demand to turn down so that we can manage the peak. We then have services around faults, so post-fault restoration, and also when we have planned outages for maintenance where we might be running other forms of generation, it would be good to be able to contract with flexibility providers behind those sorts of substations. So those are the main ones for DSO. We then also want to look at stacking services. So this is services that come from the ESO and potentially the DSO together, and if there's any conflicts of interest or unintended consequence when stacking services. And then there's also the slightly more complex area of peer-to-peer energy exchange, where you can potentially exchange capacity with another distributed energy resource, or you can do things like offsetting, where you're actually exchanging energy to be able to balance behind a primary substation, for example.
So, for example, if I'm happy, say, to sign up my fridge and freezer to be turned off remotely at times of when there's high demand on the grid, that's an example of a very local, behind the meter flexible service.
It is a flexible service, but we would probably be dealing with an intermediary there, like an aggregator, so that they would all be added together and they would be visible on our systems. Otherwise, just one is probably not going to be visible enough. So we're looking for aggregated load changes.
Thank you. Actually, this is a question that I've found sparks a bit of a response. So for everybody, I want you to just kind of like wave in terms of what you think. So for example, would you be happy to sign up your fridge and freezer, for example, to be remotely turned off for like 5 minutes, with the reassurance that the internal temperature of that device would not degrade over that amount of time, so your food won't go off, but it is a way of being flexible towards some sort of smart system. So if you would be happy to sign up to such a thing, can you just wave your hand? And if you are not happy, you do not want anyone to remotely take control of your white goods, please wave your hand now like this. Oh, that's amazing. So most people waved. Most people would be happy to sign up to this. So this is really interesting. Sometimes in one of our energy meetings, there have been like a very sharp divide and people were not happy in any way. But so that's very, very, very reassuring. Okay. So more questions. Speaking more about flexibility, there's a question about the flexibility box, Sarah, that you put.
Yeah.
Is there any study into the potential of the different dimensions of flexibility services?
Not that I know of. I think the main point we were making was that you have to consider all three, and they interact. Yeah, and you actually can't get anything much if you're only looking on one dimension. Often, yeah.
Okay. So there's a question of if people did want to participate, do they need a smart meter? I mean, in the UK, the rollout of smart meters has been subject to some controversy. Is that a requirement? Because that might disable a lot of people from wanting to participate in these schemes. Does anyone know?
It's a good question. So some form of metering will be required in order for validation of the service to occur. Exactly what that is at the moment is kind of still up for debate, because hopefully going forward the smart meters will certainly become a part of that. But depending on the rollout and the actual functionality of those smart meters and how that fits with the types of flexibility services is all kind of questions that still need answering.
Yeah, I mean, sorry, you're 1 year into this very large-ranging project, but we want you to have the answers immediately. There's a question about storage, asking if Project Leo is entirely reliant on distributed battery storage, or other types of storage that the project might be examining.
Yeah, so there is other storage types. So one of the other trials that we've been running is actually at a micro hydro on the River Thames. And there we're looking at how we can use storage actually within the river itself to kind of do small amounts of shifting of energy and peak shaving for kind of local neighborhoods around those assets. We're also focusing quite heavily on demand side response services, starting off within the university buildings. And there we're looking at thermal storage associated with the buildings themselves. And so we're focused on particularly libraries at the moment, because the books actually work very well as thermal stores. And so you can vary the heating and cooling of those buildings in order to give you a flex in terms of the electricity.
Thank you. So another question more about the people side, or the partners and the participants. So someone responded to my question about the fridge, saying, well, it's all about trust. It depends who is, quite right. And we've seen various data and internet breaches in companies that you think would have very robust systems. So that is a concern as we go forward in this technological modern age. But going more about the participants in a future local energy system, what's the balance of risk and reward? If the project is successful, who really benefits? Will there be a difference in those who participate and therefore who will benefit, and be that financially or in other aspects, to those who don't? How do we make sure there's no chasm between those two groups of people?
I think you could say that if this works well, everybody benefits indirectly, in that we keep on having a well-functioning electricity system. And I saw another question was about, what happens when how would this be different if you go out of trial conditions? But one of the fascinating things about this trial is that, yes, it's a trial of sorts, but actually it's in completely real life, normal conditions. So we're experimenting, but we have to keep the network going just like it always does. SSEN have to keep the network going just as it always does for everybody throughout. So, it's quite a special trial in those terms. So you'd hope that everyone would gain indirectly from that. But I think the question of who gains directly is really a big one to wrestle with, because we're trying to do it through a market system. And history tells us that on the whole, poor people find it hard to do well out of markets. And the way the energy system is changing, it means that we're not just, it's not just a matter of you pay your bill for the kilowatt hours you use. It's about the sort of assets you own, how flexible your demand is, can you sell that? Do you have batteries? Do you have an electric vehicle? You know, do you have solar PV on your roof and so on? Do you have access to these assets? So, I mean, one thing to look at would be community ownership of assets, and arrangements for community benefit from assets, depending on how things are set up at a very local level. But yeah, it's something that does need really close watching.
Okay, thank you. We are running out of time. I always knew that 1 hour would not be enough for this session, but it's a convenient time duration to hear the essences of the subject. So thank you very much to all of you for joining. It's been fantastic to see you and receive your comments and questions. As I've said, I will be making a recording of the presentations available, and I'll send a link round to when that is ready. But I would like to thank Sarah, Scott and Mel for speaking today, and for all of you. So let's all give each other a wave to say thank you and goodbye, and hopefully see you at another webinar that we're running in our series. Thank you very much, everybody. Goodbye.
Thank you. Bye.